Okay, so we start or
Yes, yes.
Oh, okay. So this works fine. We have 6 minutes, 7 minutes.
7 minutes.
Okay. He's Swiss. I mean
Swiss
or
time.
German.
Swiss time.
Well, I brought my
Okay.
Swiss watch with me.
So let me start by explaining this approach to risk. It's quite different from, I wouldn't say the conventional one, because that used to be the conventional one until we invented something, a field called risk management. This cup is fragile. It is fragile because it doesn't like volatility and has very specific attributes, sensitivity to volatility. We're going to start with the first mistake we tend to make in risk management and in a lot of research we do in probability theory, is that what matters for me is my exposure, okay, what happens to me. What people tend to study is a random variable. So there's that conflation between a variable and the exposure to that variable. Very often, the risk or the source of risk is extremely hard to compute, but I can avoid, instead of wasting my time trying to compute the statistical properties, which I will never get, I can change my exposure. It's called a convex transformation. And in fact, matters a lot more. And I remember a fellow who one day told me, people overpay for quants. We need lawyers more than quants. In other words, your contract you need to have, all right, is vastly more important to the exposure than the variable itself. So that's the first error. Second error here, which will allow me to voice my displeasure with that term called resilience, which is absolutely meaningless scientifically and overabused. So, which is as follows. This is a high water mark. We have the tendency to believe, to take the high water mark, how high did the Nile rise, as the scribes in ancient Egypt did, measure and think that, hey, it's not going to be worse. So try to hedge to that. That's called, hedging to the past worse. And that's an error. I call it the Lucretius problem, because he said that the fool thinks that the tallest possible mountain equals the tallest mountain he has seen. Now, this is important for two things, because when you look at natural things, even your human body, it doesn't adjust to the worst past, it adjusts to something higher. It takes the exposure from the past and prepares for higher. It's a mechanism called overcompensation. In medicine, hormesis. This is very important because your brain doesn't. So when you study risk, you're not as good as when you act based on your perception of risk. This is very important. It defines anti-fragility, the difference between fragility, anti-fragility, and robustness. We don't have a lot of time, but the way view things is in terms of, do you have a concave exposure to the source of risk? Because again, I'm talking about exposure. I couldn't care less about risk. I care how it affects me. Is it concave or is it convex? Concave means accelerated harm. Is it convex? Now, it's very interesting that by theorem, we figure out there's a link between what is concave and what is fragile. If you're fragile, then you're necessarily concave to a source of risk. If you take that coffee cup, it is fragile. It means it has more downside than upside from earthquakes. The exposure is asymmetric. So that asymmetry, okay, you can divide it and you can use it for a lot of things. Namely, to figure out the following, is that what is fragile has to have an accelerated negative response to a random variable. It's necessary, and we'll argue about it perhaps later. It's vastly more interesting than disagreement about swans and animals and dragons and stuff, figuring out. Why is it so? Because everything that survived that is linear has gone bust. This is, for example, you see the graph here. This is a coffee cup, source of stress on the horizontal. I had to use graphs. It's easier for me to communicate. If you see the one that is more linear is more exposed because the harm, I don't know if I have a pointer here, the harm is on the left side of the graph. So whatever is exposed to harm in a linear way, is linear to harm, is gone. What is left is what only blows up if there's a large deviation. And that has to have these attributes. It's a little technical, but in 7 minutes I can't do a lot better than that. Am I done, or can I have how many more minutes?
No.
Okay, sorry. Should I go further? Okay, so I pretty much, go back. I pretty much have explained my point that everything in nature likes these things or doesn't like these things up to some degree. This is how things are in nature. Typically you have an S-curve response. That S-curve can take a lot of shapes. The part that is convex of the S-curve loves randomness, variability, time. The part that is concave doesn't like variability, doesn't like time. And some things likes variability up to a point, don't like it beyond that. And risk is linked to that concept. We'll elucidate later. I wanted to use graphs because it's hard to explain in words what a graph can do, and hopefully we'll start the conversation.
Thank you very much.
Thanks.
Thank you very much.
Yeah.
My turn? Okay.
You can use my slides.
So, yeah, okay. Now you should go back. Yeah, what is this? Okay. So what are these different systems? What do these different systems have in common? I would claim that these and many others went through dynamical processes that make them knowable and to some degree predictable, to some degree. So what is the underlying process that I would like to discuss? Well, I view the world of these extreme events through the lenses of the term I introduced, this Dragon King. Let me tell you what is a Dragon King. This is an illustration in the case of financial markets where you look on the upper right at a time series of price, let's say Nasdaq Composite, and I outline in red what really investors are sensitive to in terms of risk, the drawdown, the peak to valleys. When you look at the statistics of these peak to valleys, you see this type of graph, which is a very nice representation, synthetic representation of the fact that, as represented by the red line, 99% of these drawdown, these risks, are captured by a relatively mild, let's say, parallel distribution. But you see in the tail these extreme events, and you recognize the dates, are as associated with great crash in the past. And it's clear that the model that parsimoniously described 99% of all events is extremely ill adapted to account for this extreme event. These are really events of a different kind, therefore Dragon King. There are different types of animals that are endowed with specific properties. Yeah? So where do Dragon King come from? The proposition is to look at the dynamical process of a progressive maturations toward instability. In physics or in mathematics, we call that phase transition, bifurcation, and so on. And so to understand the danger of linear thinking and the existence of bifurcation, you can think of this example of a test tube filled with water, a given mass of water, progressively hit from below, and you have the question of whether, you can predict what is going to happen. And of course, the collective phenomenon that is going to occur is this ebullition, a fundamental change of regime upon this slow changing of the condition. And the key point is that for the poor water molecules, the ensemble of collective agents, if you like, this is really a catastrophe, something that actually can be predicted if you understand the underlying process. And this is the way I like to think about financial markets and many other extreme events that occur, like financial crashes, as the result of a collective behavior of herding agents that prepare this bifurcation. Now, the good news. The bad news is that the Dragon King, the extreme events, occur much more frequently that you would obtain, that was the first slide, from an extrapolation of the calibration from the small events. The good news is that from the theory of bifurcations and dynamical system, we have learned about this fundamental reduction theorem. And the fundamental reduction theorem says that when we are flying somewhere, when we are trying to see a system, most of the time we don't predict. We cannot predict, so complex. But close to bifurcation, you have a window of visibility. It's like flying in the cloud and so on, and then when you approach the mountain, you get out of the fog and you see it coming. So this is actually captured by this theorem, and it gives rise to a process, to a program of understanding. The idea that you can actually classify the 18 fundamental bifurcation classes that exhaust all possible ways of transitioning from one regime to another. So I'm thinking of the world in terms of change of regime. In general, no predictability or very hard, but close to change regime, some predictability. So it gives rise to a possibility, dynamical process of indeed understanding and developing some kind of predictability. So can we implement this, so predictability in practice? So this is an example that we have developed at ETH Zurich since 2008, and it has been scaling up. And this financial crisis observatory that we have developed was really, for me, a reaction to the disgust that I developed from the official statement that the financial crisis in 2008 was a big surprise, was a black swan. And of course, Nassim also, we have had a lot of conversation, we agree, and we can debate on this also, that it was not a black swan. It was clearly visible, not in details, but it was clearly visible that something was going to happen. And we have been developing this process, testing scientifically these two hypotheses, whether indeed excess in financial market can be known in advance, can be diagnosed before the burst confirmed existence, and whether indeed their termination, the critical time, could be actually bracketed using probability techniques. And you see here a few graphs exhibiting ex-ante real-time implementation of our financial crisis observatory, actually in advance with publication, with trading implementation, showing indeed that it should be possible, that never again we go through this process of extremely damaging crisis where the policymakers and the analysts and so on conclude that, yeah, we are just, under the wrath of God, and this was not knowable in advance. So this is the way it looks like. You are welcome to actually access our public platform here, which is not showing everything because there's a lot of issues of liability and so on. But you see here the early warning signal in red, implemented in real time for the NASDAQ company index again, and the bottom shows the end of bubble signal. And you are welcome to test it, to use it, and so on, and to come back to our group in order to improve the discussion and the process. Now, this type of knowledge, I think, should empower us to go to the next stage, which is control. And I'm happy to report, of course, it's a control system. It's not at the scale of the full financial market, but we have been able to show that in some circumstances, when we understand the dynamics of the system, when the system shows this parallel distribution of events with the Dragon King, by very tiny perturbation at the right moment, you can actually control these dragons, kill them, slay the Dragon Kings. Fantastic achievement, both numerically and in experiments in the laboratory. So this is summarizing my view, and the view, I would say, of hundreds and thousands of research papers looking at the complexity of dynamical systems. And I see it's a kind of predictability diagram based on two dimensions. One is the heterogeneity, diversity, the variability, if you like, of the different elements in the system. And the other axis shows the level of coupling, the level of interaction. Yeah, I will finish. And what you see that there is a non-predictability part, the black swan part, which is part of a larger framework, which is controlled by these two variables. And you go to the Dragon King, the predictability part, to some degree, corresponding to this synchronization of risks. And this also can be applied in the positive side, not only for extreme destructive crises, but for example, analyzing the commercial success of books, Nassim, of videos on YouTube, of movies on Hollywood and so on, that can be also characterized in a 2x2 diagram in terms of the possibility to classifying their nature, quality, junk, vero, in a dynamical process. So what I want to really put on the debate is that my claim is that most extreme events that we care about are actually resulting from endogenous crises. These crises result from a maturation towards instability. They are a signature of change of regime. There is a degree of predictability as a consequence of the endogeneity and the verification. Very important. Therefore, there is responsibility and accountability and the possibility of control.
Thank you.
And if you want to know more, this is a book where it is.
Not at the moment. Thank you.
You should have,
But you have
Let
time.
me speak,
You will speak
after.
later more.
Yeah, so
I
I
had
take,
to squeeze all these slides in 5
and
minutes.
he was 2 minutes longer than you.
I saw he lives in Switzerland. In Switzerland, don't you get the discipline of ETH?
Okay, comment. So what is your reaction on that, what you have heard before? Do you want to add something?
Yeah, okay, let me do something to clear up that business of Black Swan, this Black Swan. I brought you a copy of the Black Swan as a gift, all right? Yes. So, and in the prologue, page 3. Thank you very much. This is very nice. This is very nice. So, and in it, so to close, so we can talk about intelligent things, all right? And in it, I talk about this building, all right? Page, the third page of in the prologue. I talk about this building. I was so irritated at people who tell me, is it a black swan, not a black swan, by explaining to them that there's no such thing as objective black swan, no more than there's such thing as non-epistemic randomness. And the whole point is as follows. This building, all right? Do you think September 11 was a black swan event?
No.
It was not a black swan event. September 11.
No.
Okay, no, that's different. Okay, my point is, was it okay for someone in a building? Was it a black swan event?
Yes.
Or otherwise,
Yes.
it won't be in a building. All right. For the pilot of the plane, was it a black swan event? No, visibly. All right. So this is my whole thing that a black swan for the turkey is not a black swan for the butcher. All right.
Yes.
And that was the definition of the whole thing. No. I mean, I'm not saying a turkey, but the definition of black swan is epistemic, largely epistemic. Okay. There are very few physical phenomena in nature that are purely random. Largely, it's because so that's sort of the point. So, what I call
you
black
agree
swan.
with me?
No. What I call black swan, what you call dragon king, are predictable large deviations, sort of predictable. That I call great swan.
Mm-hmm.
But this is not good news, actually. All right, we're going to see why it's not good news because I agree, but we can start disagreeing on something. All right, okay. I agree with your representation. I think it is rigorous and mathematically rigorous, but it has severe problems in its application, which is as follows: that I learned from calibrating distribution, is that small little changes in your model change the output dramatically. You see, and let me give you a very simple example. When I calibrate the power law, okay, I have the alpha of the power law. Take the alpha of power law, and I actually used your book with my students as a way to learn about power laws. But there's one thing you notice is that small probabilities are very sensitive to small changes in the alpha. So if you change the alpha between 2 and 3, for example, an event that happens every 5 million years happens now every 600 days. Okay? And that was my point. So I agree with your representation so long as you don't bring it down to very precise prediction. But let me give you good news. But let me give you good news now. You had so much time up there,
Yeah.
Okay.
I have to
We need equity.
Wow.
I'm telling you, what I agree with your representation is, you remember, I put these slides that were incomprehensible early on. They'll be more comprehensible as we go. Well, the following statement. I was a trader for 21 years. I had hair when I started, all right? Okay, so, and one thing you learn as a trader is that it's not your opinion that will ever make you money or make you bankrupt. You know what will really make it or break it for you? Is how you express your opinion. The financial instrument or the strategy is vastly more important than whether you guess right. You see, for example, if you use options and they're convex, you could be wrong 99% of the time. You'll still be okay. You see, so your strategy, all right, okay, is not. I don't believe can lend itself to regular prediction. On the other hand, as a conceptual framework expressed with the right financial instrument, see, you can do okay. And let me give you an example. You've seen gold collapsing. I know a lot of people who make a fortune during the collapse of gold, long gold. Why? Because the strategy, the minute you have a convex or concave strategy, and this is the third slide, see, progressively I'm explaining my slides, you divorce yourself from the statistical property of the underlying. by having smaller losses when you're wrong and much bigger profits when you're right. And this is what matters a lot more. And this is what's not understood by people who casually look at statistical data, all right, and think it maps directly into performance.
Okay. Didier, and then I would like to ask you about your reaction. We have learned it is a gray swan.
Sorry?
There's also, we have a black swan.
Yeah, I call these class. It's Mandelbrot who called them. I was arguing with them. Right? Yeah. These are. Then we called them gray swan, and we gave him, and he put the stamp. But I'm glad now we have the book. You can keep calling Dragon King and so on, but they're not too different from gray swan.
Okay, so maybe you can comment.
But this is not the important part. The important part is not the fact that they're gray. Is not important for as animals competing for subtitles, but it's important because the fact that they're gray makes them weakly predictable, right? Not strongly predictable.
Okay.
So yeah, there's so much thing to say. So very brief. I try. Dragon Kings. Why king? This is a king effect. You all know maybe the king effect, which is you have a parallel distribution. It's called a Pareto distribution of wealth, of incomes. But in addition, you have the king family in many countries, which is way beyond actually this population, the king effect. So it's not just a gray swan, it's a king effect, dragon king.
It is a gray swan.
And secondly,
black swan is not Pareto.
I let you speak. Let me speak a little bit. So, yes, what else? Dragon, like animals, but mystical animals, special properties. That's exactly what are the dragon kings, with predictable, without outlier type. Second point, excuse me, Nassim, you're not going to like it. You confuse a little bit these parallels and parallels. You are speaking about parallels in terms of statistics, and indeed the fragility of the estimation with respect to a few tail events. I'm speaking of a different type of predictive model, which is fundamentally dynamics, not statistics. That is the underlying theme of everything I showed, and actually the difference and the thing that I'm trying to promote is the idea that by emphasizing the dynamics, deciphering the structure, you can do much more than a static view. And that brings me to, and by the way, we call it, let's say, hyperbolic parallel, but it has nothing to do with the parallel distribution. So there's a lot of confusion by laymen and so on in confusing these two parallels and in terms of the sensitivity. Last comment, very quick, because I need to react also on what you said. Your view exactly is, for me, a static view. The anti-fragility, when you show the vase or it's a static view.
Wait. Static reduction.
Yeah, it's the static representation.
Representation.
Yeah. While actually, I think that we can be much more powerful, but looking at the whatever term, risk, vulnerability, and also advanced warning systems in a dynamical framework. I have so many evidence in the last 20 years of our research, from epilepsy seizure to predicting successes in books, in sales, and so on, in innovation, by looking at not the statistic as if the system was stationary. It's true that you can lose this information by looking at stationary properties like an insurer, but actually there's a lot of dynamics that actually move the system closer and closer to this critical bifurcation point or away from them. So I see the world much more as punctuated by process birth, by building up of power. And if you take that into account, you get some probabilistic predictability. And this, in my opinion, is a domain of research and investigation which is extraordinarily empowering as opposed to a more static view. And so, for example, my criticism is anti-fragility, interesting concept and so on, but too static.
To following your comment, Nassim, to Didier, and then of course we'll also have a chance to respond. So he mentioned that he likes your approach, and but the results are too sensitive to, for instance, the alpha exponent.
And or other parameters.
Yeah, or to parameters, and we cannot be sure that the parameters we are using are the right ones. So the sensitivity of the final results to assumptions we put into. And can you comment on that?
Yes. The key idea is not to search for predictability at all times. As I briefly explained in my slides, essentially you have pockets of predictability where indeed you can avoid in large part this sensitivity on misspecification and things like that. The big error of many predictors or many analysts is to try to develop whatever artificial intelligent neural network or very sophisticated neural system with parameters and so on, analyzing the sensitivity, is to try to have a statement all the time. And this is actually, in my opinion, a bad starter, because it forces the predictive system, the model, to learn or to try to decipher which is mostly noise most of the time. And actually it's a theorem in algorithmic complexity and in general dynamical system theory that with probability 1, you take a dynamical system at a random, it will be utterly, fundamentally, irreducibly, computationally irreducible, cannot be calculated, cannot be predicted. Except that when you coarse grain and you ask questions at the right level through a process, for example, in physics, which is called renormalization group, and you only identify these pockets of predictability, that's where actually you can have much better results. This, I see it all the time, for example, in financial market. You try to develop a trading strategy which is working all the time, it will not be correct. If you try to focus on these pockets of predictability, having a time dynamics, then you have a much better skill. So that's one answer, and actually I already answered to this by saying there's a misconception or confusion between the power laws. I'm not speaking of power laws in the statistical sense, this power law distribution, heavy tail, fat tail. I'm speaking of the dynamic processes that can give rise, let's say, super exponential dynamics. And in this case, you have extremely robust behavior that are broadly insensitive as an ensemble once the signal is there. So in these pockets of predictability. Well, so in a sense of an ensemble of predictors.
Nathan, so we know that the systems we are talking about, that's why we are here, they show dynamic emergent behavior. So, and he says, well, we have to have dynamic models. And he says, well, your approach is static. And this, I think it's positive to go into this direction of becoming more dynamic. And the other good story is that we get some information showing us that the system will change its behavior, and we have a chance to do something. What do you say to that?
Okay, the first thing I want to show, there's a lot of things the French call dialogue de sourds, where people are talking past each other, because you talk two different things that are not overlapping. You try to make them overlapping, and this is. So let me go back, reframe it. I work in engineering, okay? An engineer's job is not to dream of the structure of the world, but to make sure the bridge doesn't collapse tomorrow, okay? So then you have to have tools that are not too complicated, that are heuristics. Someone mentioned heuristics earlier, and that's precisely what we get out of the exercise, heuristics, to figure out if this bridge is going to withstand some kind of shocks and stuff like that. And what bridge is more fragile than the other? You can measure fragility, okay? Measure fragility. He's a physicist. The physicist has a theoretical representation of the world, and necessarily you have to specify dynamics. That's your job, okay?
I'm not a physicist.
No, okay, so what are you now?
A polyglot of science.
Oh, whatever. Okay, so you are, let's put it this way, you are whatever you call a polyglot of science, but...
Of science.
Okay,
Science polyglot.
Yeah, science polyglot. No, but let's call it a theoretician, right?
Yeah. Physicist,
so
economist.
You have to get the dynamics or econophysics and stuff like that, part of it, the dynamics of the process. Now, what I suggest is very simple tricks to figure out if the thing's going to fall apart. But it's very nice to have the dynamics of the process. And I truly believe, as you say, that there are basins, okay, that there are things you can do. But so far, and I told you, I started trading when I had a lot of hair, all right? And then progressively I lost my hair. And during this period, I've seen a lot of people trying to fit dynamics.
You see, I'm still keeping my hair.
Okay,
and we're trading.
Okay.
Without system.
So
must be a telephone.
Maybe. But I'm saying that you have the figuring out dynamics is a very good story, and it's definitely, and I believe in it. Okay. However, you don't want your brain surgeon to do dynamics tomorrow when he performs brain surgery. You want him to be a much better micro risk manager, and leave it to the evening when you have a drink with friends. Then you can think of the world. But trying to run the world and manage the world using sort of what I call overly predictive framework is not good. But how, on the other hand, I would definitely, if you gave me a call and said there's something like that, I may buy some options. You see the idea? I am not discounting that what you're doing is a very good way to view the world. It has some mathematical rigor. It is in compliance with, as you said, with unpredictability in these class of systems. However, you cannot use it neither to manage risk, nor, I think, to make a living with this. You have to have the price of financial instruments built in. You have to have much more information. This is why I've never seen it.
Okay, so I have to.
I would just say it's not because you have not seen it that something is impossible.
It's not because, sorry?
Something that's not yet been done that it cannot be done.
I'm not saying it's impossible. I am not saying it's impossible. I'm saying it's not as robust as trying to be a good engineer to make sure that the truck doesn't fall in the Hudson River.
But as an engineer, just briefly, 30 seconds, you would like actually to monitor in time, in the time dynamics, recording the acoustic emission, the non-destructive technique methods, in order to see in the time domain that the bridge is not just for tomorrow, but whether it is going to collapse. And indeed, you need the time dimension.
So I would like to open the discussion now to the auditorium. Please keep in mind that we have to stop by 6:30.
Yeah, there are drinks.
Well, he has to leave. You have to, at 6:30. You have to leave at 7. We all are keen on enjoying drinks, and so let's start. Who will be the first? Oh, there is a line. Please be short and also provide short answers.
My question is for Professor Taleb. I know you weren't here for the whole lectures, but what is being discussed here today and yesterday, do you not see that, or would you say that what they're doing in the long term, the suggestions that they're proposing and stuff like that, is actually increasing systemic risk or systemic exposure, and that regulation and maybe the state apparatus is doing that in the long term, that there will be more systemic exposure and risk, or to black swan?
Typically, all I can say is that when states intervene to try to make things better, about half the time they make things better. The other half, they make things a lot worse. As I heard when I walked in about the biofuels, right? You solve the problem by creating immediately another problem, which will require other high-paid civil servants to solve that problem, and so on. So there are a lot of things. So I think we should go by heuristics rather than go by large-scale state-sponsored techniques. You find the minimum here, because things that don't have a lot of side effects, and there is a very, very easy way to identify those.
Okay, thank you. The next, please.
I'm probably a polyglot physician, and I just want to say that I see now, with what's known as the quantified self, with everybody with mobile phones monitoring and tracking themselves all day, people are starting to predict with this dynamic system, people with diseases will behave in a particular way at a particular time, and therefore they can pre-predict. I'm also suggesting that behavior actually causes the disease, so it's a dynamic system. That doesn't mean that the old system is totally wrong, that biomedical Descartesian system, but the dynamical system hasn't been there before, and it's the opportunity now with mobile phones and so forth, and GPS tracking is for this system to come, and I predict a major bifurcation in the health services with large closure of hospitals, reduction in hospitals, and increasing wellness, although we're not going to miss the bifurcation of death.
Is that a comment or a question?
It's a question to Didier and Nassim in particular as to what they're feeling. Is that consistent with their view of the world?
Yeah, I can comment. Maybe.
Yeah, but I don't want to.
You allow me to speak. You
you
okay. Thank you. Actually, we don't need. I have a strong view on this. We don't need actually this IT system or this stuff. You already know actually, and we fully understand that 97% of cancers are environmental, 3% are genetics. We put all the money on the 3%, and actually we know that there's a understood process, I mean, overall, where you start to have a little sign, dynamically again, little sign of problem, you have inflammation that becomes generalized, that build up, destroy your defense system, that you go to chronic disease and so on. So there's a whole dynamical maturation to a critical instability, sorry to say it again, which is also seen very visibly in the health science, and actually you can actually start from now, today, start to monitor yourself, just feeling yourself, how you behave and so on, and monitoring how there is a drift. Monitoring, measuring drift, measuring trends, be, let's say, conscious of tiny little pain, tiny little thing that you put aside because you don't want to take into account this. This is the same thing at the engineering level when most of people in risk management say, oh, this is a new thing, I have to maintain more, do new things. And actually, this is a tell sign of a maturation towards a critical thing. So I'm completely on page with you on this.
I have one comment on sort of like use it, but related, but about your thing. The economists, they're not the brightest. They're not as sophisticated as you mathematically, and don't have as clean a view as one by econophysicists and stuff like that. But they figured out something a long time ago. Milton Friedman and then Lucas with the Lucas critique. You know the Lucas critique. It tells you the following: that once the statistical properties become detectable by intelligent people who read your papers and own computers, a lot of people own computers these days, and have friends who own computers and stuff and work in basements, and then you have a lot of people who all have access to screens. Once the statistical properties become detectable, then become self-canceling. All right, it would be, and that's pretty much the Lucas critique, and later on there's another English guy with this. So that is the big problem you have with trying to work with dynamics, is that unfortunately we are not a particle in water. We are humans who understand, and we're part of the system. Okay.
Take it, please.
Yes, I have a question to Didier. You were making a very interesting comment that as you see bubbles building up, that also implies some accountability of those who are contributing to them or those who are not, stopping them from bursting and creating damage to our economy or in society. But how in practice, do you exercise this accountability? Who is accountable and how do you split it up over all the different stakeholders in the system?
Accountabilities.
So, my way of addressing this very difficult question, of course, is to go to the root cause of the crisis. Let's take the concrete example of 2008, 2007, 2008 crisis. Our own work research determined or diagnosed this crisis going back roughly 30 years earlier, in the beginning of 1980s, through a process of deregulations, of growth of the financial industry, of indebtedness of the private sector, and so on, that built bubbles after bubbles after bubbles and loose monetary policy and so on. So in order to address this accountability, we need to have this broad synthetic view of not, putting the finger or pointing the finger on the proximal, let's say, dynamics just in the last year or something like that, and say, okay, this is the rating agency. It's a whole process where I have dozens of problems combining together through positive feedback. So it's a society-wide phenomenon. In a sense, all of us are culprit in this situation by believing in what I call an illusion of perpetual money machine, of living above our means. And so the question is, of course, it's easy to find a scapegoat, and so on. So accountability, I think you would say skin in the game, right? I mean, you would like actually to punish those who take choice or decisions which they don't support the consequence. So that would be also, I completely agree 100%.
Okay. One thing, the idea, the skin in the game, let me enter that, is usually misunderstood as being only a deterrent. Punishment is a deterrent. For me, it's an idiot filter. Skin in the game. It means that if you're a risk taker and you're not good at it, you harm others, you exit the pool, right? Just like bad drivers tend to die. So they kill fewer people because they die. If they didn't die, they'd be killing more people. That's sort of like the idea of skin in the game, largely. And that would be something of interest to you later with the dynamics.
Okay, so
survival state.
Let's
This side too,
Good.
please.
Oh, we got people over here.
I decided.
Oh, wow, I did. So
We are
just,
blinded.
just
We
a
are
moment, just a moment. So let's give him a chance.
Yes.
I think there are 3 remaining questions, so and then we have to close.
Yes. So again, this is directed at Taleb. Also, others may chime in on this. You've written much about option value ever since there's the interview with Gladwell over a decade ago. Option value as in just keep buying options, never sell them. That was just what I got from it. And I've seen quite a number of critiques of that strategy, but not just in financial markets, but also any moment you could apply it. So you've mentioned that in your book, Anti-Fragile. So how would you respond to those, again, to some of the critiques of, again, this buying options, never selling?
Yeah, let me, it's nice to be filmed for this answer. Most people who say that owning option is not profitable tend to work for a living. Right? That's the problem with that. So if you look at the studies done on tail options, you will notice one thing that's quite shocking, is that the rigor in them is 0. Okay, they use for proxy different domains, and they don't take into account his possibility of having his king, what we call Dragon King. All right, his Dragon King. You see, I'm using real terms. His Dragon King, the small probability of Dragon King would change the pricing of the option. And for example, you know that selling optionality, all right, has never made any money in history. And to prove the banks, for example, they keep saying it's profitable. They lost in 2007, 2008, 4.7 trillion, before we bailed them out. And they keep selling tail options. So selling tails has not been profitable historically. Owning tails has been profitable historically. Yet academics are convinced that selling tails is not good and owning tails. That's why they're academics.
I have a question for Professor Sornette to better understand the difference between a black swan and the Dragon King event. So, the success of the first Harry Potter book, would you consider that a Dragon King event? And was that predictable in any way?
Yeah, the first book was actually a word of mouth effect, which I call an endogenous viral effect. So you could not really predict it, but you could see the dynamics, as opposed, let's say, to the exogenous big advertisement where you artificially push up, the sales of a book or any commercial product independently of its intrinsic value. So in a sense, yes, you could predict the Harry Potter's first book from an early analysis of the dynamics, and actually this was one of my last slides showing this matrix of 2, viral, junk, and critical, and so on, where you can actually, from the early dynamics, and we are working with commercial enterprise to actually develop this in a dynamic framework, to predict the development of the possibility of success in this context. So in that case, so there is a predictability from the dynamics. Now, Dragon King, not sure. I would have to see. Don't know.
Okay. So that is the last question. So I think we are approaching 6:30. So please be short, if possible.
So there was a physicist discussed, there was engineering discussed, I'm a biologist, and I have a question on prediction. So we are asked always for predictions. The question is, which of your theories, or either one of your theories, can predict a financial crisis in 2016 or 2017, or whichever year you name it? But how much can you predict into the future?
Okay, the idea of detecting fragility is not predictive at all. It tells you very simply that if this coffee cup, you're not working on earthquake. You say if there's an earthquake, magnitude 2.0, this coffee cup will break. So if you look at a financial system, you can assess it at any point in time, which is what I did in actually the Black Swan, 2007. I prefer to talk about crises before they happen rather than after. All right. That's a preference. I was discussing Syria or Fannie Mae, for example, or the financial system. The thing is, it is designed in a way, it gets in a situation where it cannot take a random event without falling apart. Okay, so you say, okay, this bridge is fragile. I'm not going to be able to predict which truck is going to break the bridge, but I can say it's fragile. And it's a good bet, for example, to try to be positioned to benefit from the collapse of the bridge if the engineers don't want to listen to me. Okay, but I'm not predicting. per se. It's not a prediction. Prediction is a misnomer.
So let me complement this. Let's take the example of this, again, 2008 crisis. So, of course, we did not predict it. Of course not. And there is, of course, this load of prediction is loaded with so many misconceptions and so on. But what we did was the following. In 2005, already we published a report, and we actually, it was referred in international journal and so on. So 1 year before the peak, that we saw a massive bubble, and we were not the only one, but very clearly, quantitatively, a massive bubble in the real estate market, as well as in other markets, that was unsustainable, and we pinpoint the peak in mid-2006. So you can go to the record and so on. So I would not call it a prediction of the crisis, but we saw the, let's say, tail sign, the many variables that were showing unsustainability and a change of regime coming in. Now, of course, when the change of regime, and this is where I often explain to my fellow economists how our approach is somehow showing more modesty, surprising paradoxically, because we don't try to predict the whole system. We don't know when the crisis is coming, what will happen, because of course the regulations are coming in, the politician, essentially you need a meta model to incorporate all the actors that are going to actually change the very dynamics that has been going on in the build-up of the crisis. So this is one way of thinking, but maybe of the possibility of predicting future crises. And we see something coming in the future. I mean, this is building up now.
Thank you very much. So this brings us to an end.
To the wine.
To the wine,